Sails pick up the wind and are then driven round exactly the same way as a child's little windmill it buys at a fair is. This then turns the huge brake wheel, which is about 9 foot diameter, and the wooden teeth, which are pear wood, then drive onto the wallower on a bevel gear arrangement, which gives us the drive of the upright shaft which runs vertically down the mill. We use pear wood basically because if you have a damage, if you have an accident, if you have a jam, that something has got to give, and it's much easier if a tooth or timber tooth gives rather than if a cast iron wheel breaks. So a cast iron wheel break, you've got a disaster. If a wooden tooth breaks, you've got a nuisance. The reason that you use pear wood is that pear wood is very tightly grained, as is all the fruit woods. It could be pear or apple or cherry, or could be one of the thorns. And these woods are tight grained and therefore allow you to work the timber in all directions without it splitting or fighting back on you. The other main features up here is the fantail, which holds the sails head to wind continuously. This works with the fantail, the red and white small bladed sails at the back of the mill, which produce a gearing which comes down into the mill and with a worm gear drives the cap round the track fixed to the inside of the brickwork. Worked it out that approximately 3,000 revolutions of the fantail are needed to bring the cap round 360 degrees. This is the bin floor for fairly obvious reasons. That, as you can see beside me here, are the two bins that we're presently forming. And the sacks brought up by the sack hoist mechanism will arrive here, arrive normally, ideally at about this level, about a metre and a half above the ground, so that the person up here moving the sacks from the sack hoist into the bins can get his shoulder underneath them and just flick them over into the bins, which is quite well thought out. The other feature up on this floor really is the holding down bolts. These hold down you can see in the slots behind me, and there's 8 of them round the walls. This holds down the track, so to make sure that the bottom track on which the cap turns, which makes sure that the cap remains level and steady. The floor on which I'm standing is removable, so that you can get a chain hoist down through the floors to pick up the stones underneath if you've got to get a stone out of the building. Stones weighing about a ton. It is quite important that you know what you're doing with a pair of stones. From here you can see the sails swinging past the windows, which is very exciting and was a tremendous delight to us when we first got the sails into motion. I think that is about all on this floor. And I suggest we go down and have a look at the stone floor. This is the basic structure, or the basic support mechanism for a pair of stones, which is quite useful. We haven't got a pair of stones on this at the moment, as you can see, but we can see here how the drive comes up from the bottom of the upright shaft, where there's a large wheel fixed, which drives a small gear wheel, which is below me here, which then turns this. And sitting across this is a bridge, which lies down on here like that. And as that turns the bridge. The bridge is built into the stone, which now is running on top of that, and that spins the stone. And I can show you the stones and what is happening more clearly over here, if you come over here. This is a pair of stones. There's the bottom stone, and this is the top stone. And this top stone is free to run, like that. And that is what the bridge we were looking at would do. That spins round the centre there. Sitting on top of this stone would then be a cover like this, and then on top of that would be this. This is the horse onto which we've got the hopper sitting. The hopper is fed from the bin floor through a chute, canvas chute, which will come down here, feeding into the hopper. Now from the hopper, we go into the shoe here. Imagine this all being a bit higher in the air. This shoe then lowers down, and there's a hole in the centre of the shoe here through which the grain drops into the eye of the stone, which is the central hole in the stone. So you've got a heap of grain in there, and then the grain comes down there. You want the grain to just feed gently. You mustn't jam a stone. If you jam a stone, you get all sorts of problems because the whole mill stops. So you just feed a little bit of grain in, exactly the right consistency. But obviously you will then get different qualities of grain. It may be a little damp in places, so it will tend to stick. So you've then got to shake it. Instead of having somebody standing up here shaking it all the time, what you do is you have fixed to the case is a whippy piece of willow. And then from that, you have a string fixed onto the shoe, which is tied across to the willow and taut, so it then pulls it across. Sitting on the bridge is this, which is a piece of metal with a shaped middle section. That then is rubbing against the side of the shoe there. And so that, as this goes round, the shoe is shaken and makes a sort of chattering noise and is called a damsel. Whether the chattering and the damsel have anything to do with each other, I don't know. The shoe is set up with this string, another string over there, which holds the shoe up, goes down over those pulleys, down through the floor to a control point below, so that the miller can then, if he knows that there's no grain coming through into there, he can then stop it. Now how he knows about that is that on the back of the hopper, he will nail the end of a belt, I mean like his own belt around his trousers, which then goes down into the grain and comes out here. And on the end of the belt is a little bell. That is then held, that belt is held down by the weight of grain. And as the grain is used up, there's less grain to hold the belt down, so the belt and the bell drop until the bell reaches the damsel and is then rattled and rings. So the miller on the floor below will then know what's happened, will walk over to the turnbuckle on that floor and just lift the shoe so that he's got no more grain going into it, and can disengage the stone so that the stone stops working, so that he's in complete control from the lower level without having to run up and down the steps. There were originally 3 stones here. There's this one, there's the one we looked at which has not got a pair on it, and there was originally a 3rd pair here which was sold away just before the First World War. And of course one feature which is very important with the stones is that they are flat and level. They're kept level by weights. They've got metal weights into the stone so that it runs without catching, which it doesn't do at the moment. And you then make it flat by using this, which is a timber which is absolutely flat. You then chalk that with red chalk, which is why it's the colour it is. And when you've got the stones open to dress them, to check them, you then run this over them. Where you get high points, the red chalk will get left behind, so you know then you've got to level them down. It's very important that this remains flat, so that you then have this cast metal bar, which is ground perfectly flat, and you check your timber against that every now and then to ensure that it hasn't warped or twisted. So you produced a fairly high quality technology, which is, I think, probably the basis for the Industrial Revolution, because the knowledge and thinking which had gone into this then goes on and is used to produce the technology needed for steam-powered engines and machinery. I think now it's worth having a look on the floor below, which is really the bridge and control room of the mill. So we'll go down there. This is the actual control which gives you power onto the mill. Pulling down on this chain here, you then, by mechanism overhead, you then close all the shutters or shades on the sails, which means that the wind is now giving you drive onto the sails, down through the brake wheel, through the wallower, down the upright shaft, to the great spur wheel, which is then driving the stones. Pulling down on that side of the chain, I then open all the shades again. This has to be outside because when the cap swings, this has to swing with it. The weights here hold the sails in the position you set them, unless the wind increases very heavily, in which case the wind will be able to lift these weights, which is about half a hundredweight, be able to lift these weights and force the shades open so that you won't damage shades with excessive wind. This is all held at this level, which gives the miller all his controls at one level, so he should be able to operate the mill most of the time without walking away from the gallery staging floor. The other control that should be down here is a rope, which we've hooked up at the moment, which is a brake mechanism, again up in the cap, which means that when you've got the shades open and you want to get on the sails, you put the brake on so that you don't have the sails moving inadvertently when you're on them. But it is not a means of stopping the sails moving. You stop the sails purely by using this chain. I think that's all we got on here. Let's go back inside and have a look at the gear and the controls in there. So following from the controls on the outside, you've now got the actual control of the milling mechanism inside. Those controls are dealing with the power source, putting the sails into operation and stopping the sails moving. Here you have the control of the stones, which are above our head. Over there will be another stone there, which is the one we were looking at, which has not got a pair of stones on it. And then you have the controls here, which this, by winding this down, we then drop stone into gear. If you look up, you can see the great spur wheel, which is fixed on the bottom of the upright shaft, which is driven from the wallower, from the brake wheel, from the sails. This is turning here, and then we have the small gear wheel here, which is known as a stone nut, which we are, by lowering this, we drop it into gear with the spur wheel. Now when the sails are turning, the spur wheel is turning. So you then drop this into gear and then start the sail moving and start power. So that then puts power onto the stone, onto the upper stone. You've got two stones, you've got a lower stone and an upper stone. Lower stone lying in its bed, so it's known as the bed stone, and then the upper stone running round, and that is known as the runner stone. So you've now got the runner stone on the move. I'll take that out of gear because we're not organised to sail at the moment. You've now got the stones running. You now want to control the gap between the stones, because depending what you're grinding, whether you're grinding meal for animal feedstuffs or wheat to produce flour or whatever, you control that by this turnbuckle here, which turns there. That lifts and lowers the runner stone, the top stone, and controls the gap. That is important, and if your stones are properly levelled, properly trued, you then get very regular fine flour. You now have a problem that as the sails speed up and slow down, the gap between the stones tends to change. As it goes faster, the gap tends to open. So you now need something to govern that and control that. If we walk over there, we can have a look and see how that's done. So this is the governor here, which controls this gap between the stones. As you saw, the governor spins when the spur wheel is going round. As it spins, it tends to lift out these weights, which are heavy lead weights, tend to lift out And as they do so, they lift this ring here. You can see that, lift that ring, which lifts this steel yard. That goes back to the stones and overrides the gap control we'd set up with the little butterfly and pulls it back down again so that you hold your gap between the stones absolutely consistent and level, and you then get good quality grinding. You get uniform particle size from the flour and from any feedstuffs you're grinding. That is basically the controls for the stones. There are one or two other things here. If we can look over there, is a power takeoff for driving machinery underneath. This is a gear which you can then lift by this wheel into engagement with the great spur wheel, which then gives us a drive onto a belt drive here, which goes round like that as the mill is driven, and that deals with a grading machine on the floor below. The flour that you've ground on the stones above you is now going through this hopper here. We will then organise chutes to come from each of the stones to go to that hopper, one coming across from this stone, coming across there, and from that stone dropping straight down into that hopper, which then goes onto the grader or wire machine on the floor below. That's all I think on this floor. So if we can move down one floor. From above we saw the shaft with a belt drive on it, which had a takeoff from the great spur wheel, and this is the underside of it. And here's the belt coming down onto this wheel, which when it dries will turn this shaft around here and turn thereby this wheel, which puts power onto the wire machine, which is in effect a grader which sorts out the quality of flour you're getting. So you've got a belt which we've got a rig which comes across here onto this wheel, which turns all this gear in here, onto which are fitted a set of brushes have been taken off. This is the best of the old ones. They will obviously have to be replaced. One of the brushes which would be bolted there, like that. Round that, those set of brushes, are fixed a cylinder, of which this is the framework. Into the cylinder is a gauze, fine gauze. That is, as I say, fitted round there. So you've now got a cylinder there. Flour comes out of this hopper inside the cylinder. So you've now got flour flowing down the cylinder. This is spinning, and the flour is being brushed through the gauze. The finest flour, semolina, comes through a hatch here and will drop through into sack-fixed little hooks on this, a sack fixed on there. The majority of the flour will come down into a sack fixed on there, will be normal wholemeal flour, and bran will go on through, will not get brushed through the gauze, and will come out at the end onto another sack, which will be just hung on the end there. That is your finished product, and the flour is then made. So you then bag up the flour, tie up the tops, and it can go out through the door behind me, dropping on a block and tackle into a cart below, and would be driven away. And that really is the end of the mill, or the bottom of the mill. The floors below us are basically there just to get the mill up into the air sufficiently high to get a good wind.